Welcome to The Explainer. Today, we're taking a look at the beautiful game through a completely unexpected, yet honestly perfectly logical lens. If you're someone who loves breaking down the mechanics of a game to understand the hidden structures right beneath the surface, well, you are in the exact right place. We're going to analyze the highly discussed France versus Spain match, but we aren't just going to talk about formations or player stats today. No, we're actually going to map the physical laws of the universe directly onto the pitch. So get ready to look at football in a way you probably never have before. So we've got to start with the absolute biggest question from that match. Why did France lose to Spain? It's a question that's sparked endless debate, right? Fans and analysts alike have been scratching their heads looking for that one specific moment or individual error that led to France's downfall. But to truly understand what happened out there, we need to completely shift our perspective and look at the systemic flow of the game. You know, when a powerhouse team loses, it is just so easy to fall back on the usual football excuses. People will say, oh, it was just bad luck, or they just had bad tactics on the day. But actually, scratch that. That is not what happened here. The reality is far more structural and, frankly, a whole lot more fascinating. France didn't lose because of a simple stroke of bad luck. They lost because their entire attacking system fundamentally operated like a very specific type of electrical circuit. While Spain was operating on a completely different, beautifully resilient electrical model.
All right, let's get into Section 1, the football circuit.
Okay, let's really dive into this. To make sense of how electrical engineering perfectly explains a football match, we need to establish our ground rules and literally map these physics concepts straight to the pitch. We're doing a double definition mapping here. So in electrical engineering, you have voltage, right? That's the electrical pressure or force. Out on the football pitch, voltage translates to talent and attacking quality, the pure offensive force a team possesses. Think Kylian Mbappe's raw, undeniable power. Next up, we have resistance. In a circuit, resistance is what fights against the flow of electricity. In our football circuit, resistance is the defense and the pressing from the opposing team, exactly like Rodri tirelessly anchoring the midfield and breaking up plays. And finally, we have the current. This is the actual flow of electricity. On the pitch, current is the attacking flow, the movement of the ball and players successfully advancing toward the goal. So keep these three things in your head. Voltage is talent, resistance is defense, and current is the attacking flow. Moving right along to Section 2, France and the series circuit. Let's apply these principles directly to France's structural setup. France built their attack exactly like a series circuit. By definition, a series circuit is an electrical setup where electricity has only one single path to flow. It's a linear journey. Because all the components are connected in one straight line, if a single connection breaks anywhere along that line, the entire circuit instantly stops functioning. On the pitch, this meant France was heavily reliant on a single, predictable attacking pathway. They continually tried to funnel the ball down the left channel, forcing absolutely everything through one specific tactical route just to advance the ball. Now, what's really interesting about this relationship is how perfectly Ohm's law explains the breakdown of that single pathway. Ohm's law basically states that current equals voltage divided by resistance. Remember our mapping? France had massive voltage. They were loaded with talented players and absolute top-tier attacking quality. But Spain realized this and countered it strategically. They didn't just sit back, they aggressively increased the defensive resistance. They pressed hard and closed down those passing lanes on the left side. So, mathematically speaking, as Spain's resistance increased, France's attacking current, their overall flow, simply had to drop. Let's see how this plays out step by step. Step 1, France establishes their single attacking path, moving the ball up the pitch. Step 2, Spain aggressively applies that defensive pressure, bringing the resistance. Step 3, the connection breaks, just like a snapped wire in a real circuit, which immediately leads to Step 4, the entire attack simply stops dead in its tracks. The flow cannot continue. So the crucial point here is understanding the actual mechanism of that break. In electrical terms, this is known as an open switch. It's a physical break in a circuit that stops the flow of current entirely. In the context of this match, think about a moment where Jesus Navas or Aymeric Laporte stepped up to flawlessly intercept a pass meant for a French forward. That specific action instantly acted as an open switch. The very moment France lost possession, their linear attacking circuit was fundamentally broken. The consequences of an open switch in a series circuit are absolute. No current, no attack, no goal. Because France relied on that one singular pathway, a single interception didn't just slow them down. It completely deactivated their offensive power. Let's jump to Section 3, Spain, and the parallel circuit. Let's see how this builds into an entirely different tactical approach. While France was struggling with their fragile single pathway, Spain brought a completely different blueprint to the pitch. Spain operated as a parallel circuit. This is a circuit designed with multiple independent pathways for electricity to flow. The real beauty of a parallel circuit is its absolute resilience. If one pathway gets blocked or severed, the current doesn't stop. It instantly, effortlessly finds another path and just keeps on flowing to its destination. This adaptability is what made Spain so incredibly difficult to shut down. Think about it. On the pitch, if France managed to stop the left wing and close down Nico Williams, it didn't matter. Spain's current just flowed right to Lamine Yamal, and they attacked down the opposite flank. If France congested and blocked the midfield, Fabian Ruiz simply bypassed the blockage, quickly switching the ball to open space. In this system, every single Spanish player became another viable electrical pathway. Because they weren't tied to a single line, Spain always found the open space. Which brings us to Section 4, the path of least resistance. But Spain didn't just maintain their flow. They literally weaponized France's broken circuit against them. And they did it by utilizing one of the most famous principles in physics. When France's series circuit broke and that switch was opened, Spain took the ball and counterattacked exactly like electricity taking the path of least resistance. Electricity naturally flows toward the area where it faces the least opposition. Spain's transitions were exactly that, incredibly fast, intensely direct, and ruthlessly efficient. Think of Dani Olmo striking rapidly through the sudden wide-open gaps in the French defense. They bypassed the heavy resistance and flowed straight toward the goal. And this brilliantly illustrates the overarching difference between the two teams on the day. On one side, you have France's series circuit, heavily reliant on one path, ultimately fragile, and failing entirely the moment a single connection broke. On the other side, you have Spain's parallel circuit, highly adaptable, utilizing multiple pathways, and capable of continually delivering power even when faced with heavy obstacles. This shows exactly why relying on pure talent, massive voltage, simply isn't enough if your structural adaptability is fragile. One system fails under pressure, the other flows right around it. It is absolutely amazing how perfectly the laws of physics can decode a complex sporting event. France lost because their attack behaved like a fragile series circuit, while Spain dominated by playing like a powerful, adaptable parallel circuit. As the saying goes, that's engineering, that's football. It really makes you wonder, doesn't it? What other invisible physical laws are quietly dictating the outcomes of the sports we watch every single weekend? Thank you so much for joining me for this explainer. Keep learning, and I'll catch you next time.